Hey everyone, this is Anit Das and you're watching HashiCorp Nomad Crash Course. Now, in this course, we'll be learning about what exactly is Nomad and why it's important. Then we'll go through in Nomad how to set it up, how to get started, and I want to keep it the first part that way. And in the next week, we'll have how to integrate with other services. So now, without any further waiting, let's get started. But before that, if you didn't subscribe my channel yet, please do subscribe the channel. And now let's get started. So let me introduce to Nomad. So what exactly is Nomad? Now Nomad is a workload orchestrator developed by the company HashiCorp, and this company is actually behind other popular tools such as Vagrant, Terraform, and the Vault, and it's also good. I mean, so many great things they have done. Now it is designed to manage and deploy application across an entire infrastructure, which can include multiple data centers and regions. So you have that level of scalability and span. Now let's learn about the reasons why we should use Nomad. First point is the simplicity. So Nomad is designed to be simple and easy to use, and it has straightforward setup process and user-friendly interface. I have tried multiple times, of course, and this can make this easier to get started with and manage compared to other complex tools. Okay, and we'll be coming with the comparisons later on. Now, flexible workload support. So Nomad support a variety of workload, including containers applications such as Docker and standalone application like standalone programming, say Python or say Java or say Go, Node.js, any kind of program. If you want to run individually without the help of Docker or containerization, you can still use Nomad to run those. Okay, and of course even virtual machines. Now this flexibility can make it a good fit for wide range of use cases. Suppose any kind of use cases where you want to mix and match your application to run, you can achieve that via Nomad. Now, the third point is scalability and performance. So Nomad is designed to be highly scalable and performant. It can handle orchestration thousands of deployment across multiple regions, making it suitable for large scale and high load environment as well. Fourth point, multi-region and multi-data center support. So Nomad support running application across multiple data centers and regions, and this can help provide high availability and reduce latency, which can be particularly important for global applications. Fifth point, integrating with other HashiCorp tool. Okay, because of course, Nomad is actually developed by HashiCorp, so it has a very tight integration with other HashiCorp tools. Now, if you already using any other HashiCorp tool such as Console for service discovery and networking, Vault for secret management, Nomad can easily integrate with these tools and provide a very cohesive and powerful tool set altogether. Okay. Now, security. So Nomad includes built-in mechanism for secure operation, including access control list or ACLs, namespaces, and sentinel policies. This can help ensure that your deployments are secure. Now, resource efficiency. Now, Nomad bin packaging algorithm help to efficiently utilize the machine resources and reduces the overall cost. Final point, community and support. Now, HashiCorp has a very strong community, provides a very good support for all of its tools, not just in a single focus. Don't do that. They have, they provide support for all kind of tools. Okay, and this can be a big advantage when you need help or say want to extend some tool capabilities. You can of course ask the community, since since the HashiCorp community is big enough. Okay, so these are the reasons I would say we can go for Nomad, but there is more. As we move forward, we'll be learning about them. Okay, now one of the biggest question ever that I have faced from many people, like there are Kubernetes, why do I invest my time in Nomad? Now let me answer that part. So before that, let's go through all the comparisons that you need to know before selecting should you go for Nomad or should you go for the Kubernetes. So here's a small comparison, compact comparison I have written. So you can see here. First, let's talk about the complexity and ease of use. Now, in case of Nomad is simpler and simple to set, simpler to configure, simpler to do all these operations. But Kubernetes is a bit more complicated with the steps like steep learning, so you need a bit more time to learn and configure things and all that. But offers a wide range of tool set and wide range of features. Okay, then let's talk about the scope. So Nomad is primarily a task scheduler and deployer. It integrates with other tools which does other stuff. Now Kubernetes is a very comprehensive platform that includes service discovery, scaling, load balancing, and more such features. Now, let's talk about the workload support. So Nomad support containerized and non-containerized application as well as virtual machines. But in case of Kubernetes, it's only primarily supports containerized applications. Okay. Then multi data center and multi region support. So Nomad natively support running application across multiple data centers and regions. Kubernetes support multi data centers and multi deployment, but it requires additional configuration. So kind of both are possible. It's just that in Nomad it's come naturally, natively. Kubernetes, you need additional configuration and tools for that. Okay. Now let's talk about the scalability. Now both are designed to be highly scalable, but Nomad simplicity can make it as simpler to manage. Okay, even though you are scaling a bit further. But for Kubernetes is very highly scalable and widely used in large scale environments. And you know what? Of course, there are some tools and configuration required, but Kubernetes is a bit more better choice if you are going for the bigger system, bigger deployment, enterprise use cases. Let's complete the community and ecosystem comparison. Now, Nomad has a smaller community but integrates really well with other HashiCorp tools. For Kubernetes, Kubernetes has a very larger community and a wide range of extensions and integration available. Kind of, since it's a bigger community, many people contribute even at the bigger level for Kubernetes. Okay, so these are the comparison. Now, if you're gonna ask me and say, Sandeep, should you go for Nomad or should you go for the Kubernetes? For that, let me say this. If you need a simple, focused tool for scheduling and deploying tasks, I would say, or maybe if you want to run a container on container on virtual directly, then this Nomad will be good choice. But if you need a comprehensive solution that includes, like, that solution should include load balancing, service discovery, and more such features in single platform, if you're looking for, then Kubernetes will be a good choice. But remember, Kubernetes will have its own complexity. So Kubernetes is actually a bit more complex than Nomad. That I also have felt multiple times while working on different projects. Okay. Now I hope you have very good idea, like, should you go for the Nomad or should you go for the Kubernetes? Now let's learn how you can install Nomad in your local machine. So for that, there is some prerequisites I want you to carefully consider. Operating system, of course, it supports on Linux, Mac, Windows. You can run it anywhere. Hardware, minimum 1 GB RAM and 1 core processor. Software, some kind of group programming and whatever is needed. Anyway, the package will automatically pre-install. If it's not installed, so it's fine. Network, of course, you need very good network. I mean, see, while running local is fine, we'll have it. For an in cloud, whatever clouds network wide services are available there, you will have there, no worries. Knowledge, now while it's not strict prerequisite, it will helpful for some knowledge of system administration, Linux knowledge or networking. It will be helpful. If you're going to work with Docker system, like running container workload, then some knowledge in container Docker will be helpful as well. Okay, now for the cloud server, you can see the requirements here. Say for this, if you like type small, 2 to 4 core memory, 8 to 16 GB RAM, disk 50 GB. If you want smaller configuration, then there is AWS M5 large or M5X large is there. For Azure is standard D2 V3, standard D4 V3 is there. For GCP, N2 standard 2 and N2 standard 4. If you want a larger system based on your workload, of course, or how many, is it a small, medium, or enterprise application that you need to run and support. Based on that, you should check that. Now, for the larger system, you have 8 to 16 core. We consider as a large server instance. That is 8 to 16 cores, 32 to 64 GB of RAM, and 100 GB of disk space. Now, disk space actually comes separately, which you can configure later on. For AWS, it's M5 2x large, M5 4x large. For Azure, standard D8 V3. For standard D16 V3. For GCP, N2 standard 8 and N2 standard 16. Now, these are just some recommendation. Based on your work usage and your requirement, you should be selecting what kind of server, what is the server type that you want to run. Okay, or that is mean that how much CPU and how much RAM you should be having. minimum requirement already see, right? Based on this application, how many say application to run and all that, I'm just recommending that one. Now this is actually from the Nomad server only, this configuration recommendation part. Now enough talk, let's get started. Let's install Nomad on your machine. Now of course, based on your operating system, the way of installing will be different. For say Mac, you just have to run brew tab HashiCorp then slash tab, then run brew install HashiCorp tab Nomad. It will install for Mac. For Linux, some commands that run say wget to face the gpg key, then add into the package list using echo dev and that command, then sudo apt update and sudo apt install Nomad. It will install the Nomad. For Windows, there is existing exe files available. Simply go and download it. That will work. Now for me, it's Mac OS that I use, and I will show how to use Mac to install Nomad. Now, let me show you. Now let's click on this download button. You'll have it in your doc that I'll be sharing with you guys. Just click on that, and that will open a screen like this. Okay, and if you come to the screen, simply go there and just make sure that you are you just come here, and this is like if you're going to install from Mac OS, then click on the Mac OS. If you're going to install for Windows, just click on this Windows tab, and if it's for Linux, just Linux. Now Linux have many flavors, right? Distributions, for example, Ubuntu or Debian, CentOS or RHEL, Fedora, Amazon Linux, Homebrew. So like Homebrew in the sense, if you are going to use Homebrew for your package management, of course. Now for me, it's Mac OS. I'll be running this command, brew tab HashiCorp tab, and brew install this command. I'll just copy, and let me go to CLI and run this. Okay. Now it seems it's reinstalled or installed for your case. Then just to check that Nomad installed properly, you should run this command. Okay, Nomad version, and if you see that, it will show Nomad version 1.5 and 6, build there and revision, all that. So that means Nomad is installed. Okay. Now there are few more steps required to configure a local system. Let me show you that. Now that we have installed Nomad in our local computer, it's time to configure the Nomad cluster in our local system. Now, how can you do that? There is actually very simple way, and you will not even believe it how easy it is. So let me show you. Now this is the cloud level configuration. For local is actually a bit easier. So let me show you quickly. Now if you go and follow the documentation that is provided by the HashiCorp itself, and I will give the links in the description section, so you can simply follow. So go to this page, getting started, simply get started, and create the cluster. Select the local tab. Okay. Now if you go there and go down, just run this command: sudo nomad agent dev, then bind your local IP, then network interfaces, and that's it. Now let's copy and let's run. Clear the screen. Of course, give the password. It will ask you, and see this got started. Now again, go to the documentation, and in another second terminal, explore the cluster address. So copy and open another terminal, and just simply export it, and let's follow the next documentation. Verify the connection. So run this nomad node status. So let's copy this command, come back and simply run. See, it's showing that DC1 something does like my MacBook. It's got started. Okay, now let's go back to the documentation. Now since the Nomad is installed and we have started a local cluster, we can actually check this this entire thing. I mean, actually what happens, Nomads gives you a web UI using which you can control certain stuff in Nomad. And that location, I mean, after you complete this starting of the cluster first, and then just export this Nomad address, and then you can access this. So simply go to this address, localhost on port 4646/UI. Okay, let's go there, and you see we have the Nomad UI available to us. And you can see here, say it will show job, storage, variables, and in the storage you have plugins also for different you can say file system plugin, those kind of thing. We'll be discussing maybe in the next sessions. Today I want to keep it very simple. Then there is clients, servers. You can see client also connected. The moment you export the server, you export the agent, that gives you server and the client. Okay, topology, you don't have to focus too much on this. Just think that these are the option available, and you will be learning a bit more about all this. Okay, so for now we have Nomad up and running in our local cluster. So okay, now that Nomad is installed and working to be fine, let me quickly show a demo of how I can run a Node.js application via container, that is via Docker. And then after that, I will describe or I will explain about the architecture. And just after that, I will explain what I did, how I run the app. But now let me quickly run the app and show you the magic. Okay. So for that, let me go into the code a bit, and here you will see this configuration. Okay, this is called node underscore job dot nomad dot hcl. Now you don't have to overcomplicate your mind. Just think carefully. I will quickly do an overview of it. First, you can see a job. So in Nomad, you'll be running jobs. Okay, I'll be showing the commands how to run jobs and all that. But for now, think that there will be a file. We call it job script or job definition, whatever you want to call it. We run this job file. Okay, and this job file extension should be .nomad.hcl as per standard. You can keep it .nomad, that's also fine, but keep it good. Okay, .nomad, like your application name, and .nomad.hcl. That should be the format. Okay, then what should be the type? Type should be service. Now if you keep it as a service, then it will keep running. If for any case your container stop, it will automatically restart. Okay, if you give it as a service, it continuously running. Then there's a group. In that group, you will be defined like this is a group. Group can have multiple things, right? Now I'll be not going to that depth. Just think there's a group, and in the group there will be networking, there will be service, there will be task. So in the network, we mention the networking part, like what is the mode? Either is the host networking or bridge networking, or could be something else. What should be the port mapping? So port mapping, you do it here for the networking level or network configuration. Then there is service. Service we maintain like what should be the service name, or should be the port, and port of course whatever you configure here, you should be using that one. And what is the provider? This is to who is providing this service. Okay, so that is we're using the Nomad only. Then in the task, it's a node task. Now if you see interestingly, here is driver is Docker. Okay, and I will be explaining what are the drivers available. Don't worry, just now understand. Okay, we are running a Docker image, and image in the config you are providing the image with image URL and the version number. Okay, and in the ports we are saying which port to use. Again, port whatever configuration you define here, will be using the same thing here. Now let me quickly run it. Okay, and then I will explain the architecture, and then we'll go through that way. Okay, first let me run this application. Now to run, we'll be using Nomad job, then like Nomad space job space, then the job name. And what is the job name here? Node underscore job dot nomad dot acl. Okay, so we'll simply run Nomad space job space run space that job file name, and then it will automatically create the container. It will automatically start the container. It will do all these things for us. Okay, so let's run it and see. You will see the deployment status, like this desired one, placed one. It should be healthy one, and then it will be, you will think that it's deployed perfectly. Okay, and by this timeline, suppose if this deployment doesn't work, it will be considered as a failed deployment. Okay, see, the healthy one, that means now our deployment successfully worked, and we should be have a running container. Okay, now let me quickly go to the browser, and let me show you in the browser how this looks like. So let's go to the job section and see there is node app job. Now if you remember, exactly same thing is here, right? This node app job. So whatever job name you specify here, that will be running in the exact area here. Okay, now let's click on the job name. In the job name we'll see the like place, desired, and healthy. So that means one healthy app is running. Okay, and if you click on this group name, so group name is group node app. Okay, the exact same thing that we have specified here. Group name is group node app. Okay, now here you will see, if you click on the group name, then you will see mainly the allocation status and all that. And if you click on this one, you see this usage, and this is the URL. If you click on this, you'll see hello world. Now why it's showing hello world? Because in our we are using a simple Node.js application. Let me show you the code of that application also, so you'll have a better idea what you're doing. So this is the code, okay? It's simply saying hello world, okay? And this is the Docker file that you have used to containerize the application. Simple Node.js 14, any Node.js version you can use, latest one. It's simply copying the packages and files, installing all the modules, like, and running on port 3000. Now if you check our job file, we have specified two port. Now two port means what is the container port, like container using which port to run your application, that you should mention in the port 3000. Now if you ever worked with Docker, you know that you can bind your random port or particular container port with your host port, okay? And that you can do with this static thing, okay? So if you mention static and then give the port, then it will be mapped with port 8080. That is the reason if you come to the browser and see that, see our local IP or this machine's IP, then 8080. That's why it mapped. What will happen if we don't mention this port 8080? Let me quickly show that part. Let me just go to job and here. Now let me quickly go to our code base and there remove this, okay? Remove this static part. Now let's deploy again. Nomad space job space run space the job file name, enter, and let's come to the browser quickly. See, placed one, desired one. Let's wait for becoming healthy, and it will be only few seconds, and it's all automatic, okay? You don't have to do anything, just check that it will become healthy. Yeah, it become healthy, right? Now click on this group node app, that's the group name, and click on the task, that the task name. If you go down, see node port, and this port become random because you didn't mention any particular port mapping. That's why it any FMO pool that is available, Docker use that one, okay? Now if you click on this, you'll see hello world again. So that's how the port mapping and all this works in simple sense. We'll go to very advanced level in next week session and upcoming sessions. But for now, think of this is the easiest way possible how you can get started with Nomad. Okay, simple applications. Okay, now that you have seen how Nomad works, at least how we can run jobs or how we can run containers, it's time to dive a bit deep into the architecture, how this works, right? Before, if I move anything further, if you don't know the architecture, if you don't know what is called what and why, that will not make sense, right? So let's understand the architecture in this today's session, and also a bit more into the job and protocols. So I'll go through very smooth way, okay? Just keep following. So first thing here we'll be learning now is that Nomad architecture. So let's go to the architecture part. So Nomad, you have a very easy architecture where after, as an admin we can run server, and server will run agents. I mean, server will be adding client agents, and we'll be running our workload on agents. Okay, now don't confuse yourself. Let's go one by one, simple way. We'll be learning all this bits and bytes of everything. Okay, so first one is that server node. So what is server nodes? So the server nodes are the brain of the cluster. They accept job submissions, determine which client should run the jobs, and monitor the cluster for failures. Then server uses the RAFT consensus protocol to handle leader election and state replication. Now, a Nomad cluster typically has an odd number of servers, such as 3, 5, to tolerate the failures and maintain the quorum. Okay. Now, the second one is that client nodes. So, what are the client nodes? Client nodes are the worker of the cluster. They run the tasks and makes up for jobs. So, any job that you run, you should be running on the client nodes. Okay. Now, each client node runs a normal Nomad agent, and which register the node with the servers first, then report on the node status and handle the task execution. Okay. Then the third point, and the one that I've just shown you earlier, that is jobs and tasks. So in Nomad, a job is a declarative specification of task to run, just like I show you a few minutes back. Each task belongs to a task group, and which is a set of tasks. So what is a task group? So in under task group, we will learn a set of tasks. Okay, maybe replicate a task, for example, and which is like all tasks will work together in more simple sense. Now, tasks can be anything from Docker containers to standard application. Even can mix and match also can happen. It's up to all to you. Okay, and in our series, of course, we'll be going through all that. Then the schedulers. So Nomad uses pluggable scheming algorithm to determine how to allocate resources to the task, and it includes several built-in schedulers for different use cases, and you can also add your customers. Okay. Then service discovery and load balancing. So Nomad integrates with HashiCorp's console for service discovery and load balancing, and this allows the tasks to find each other and distribute traffic. In next week, we'll be learning that. Okay. And the next one is secret management. Now, Nomad integrates with HashiCorp's Vault for secret management, and this allows the task to securely access secrets like API keys, password, like most secret things. Okay, and then you have the web UI. So Nomad include a web UI. I just shown you how the UI looks and all. So that way provides a visual way to interact with the cluster, and you can use it to view the status of the jobs and task as well. And you can also submit a new job. Let me show you how you can submit a new job. Okay, so let's go to the browser and quickly show you how can you submit a job. So if you click on this run job, okay, see there's a job definition, and you can say this one. Just what I'll do, I'll change the name of the job. Okay, the job note app job 2. Okay, and you can plan works. So it's kind of a dry run. Okay, if you run the plan, there's a dry run. Simply click on run, it will be actually running this time. Okay, and see one is running, so paired and one desired, it will automatically become, after a few minutes it will become healthy. Okay, so now let's go and see become healthy, so it's also now available. Okay, now let's go back to the slides. Now you understand all these things. What are server nodes? At the beginning only when configuring you understand. Client nodes and server node will be learning a bit more further in the next week when we configure in the AWS console all these client nodes and all that. Okay, now next is the understanding the server agents and the client agents. Okay, what are those? So server agents participate in the consensus protocol, maintain cluster state, and schedule the jobs. Okay, and they are the brains of the cluster that makes decision about which task should be running and like where should be running. And server agents communicate with each other to maintain a consistent view of the cluster and replicate data in normal production cluster or Nomad cluster. A typical setup should be 3 or 5 or maybe kind of a odd number of clusters to handle the fault failures or tolerate the failures. Okay, then the client agents. So client agents are responsible for running the task only. Okay, when a server agent assign a task to a client, the client agent start the task and monitors the progress. Okay, and it also report back to the server agents on the status of the task. Is it running? Is it failed? What is happening? Okay, all those things it report back. Okay, and there are typically many more client agents than the server agents. Okay, so you will have more clients than the servers, of course. Now both server and clients run the same Nomad binary, but with different configuration options. Each agent maintains a local state and communicates with the agents with other agents as needed, and the agents also expose an API for operators to interact with the cluster and manage the jobs. So in summary, Nomad agents, whether server or client, are the fundamental building blocks of the Nomad cluster, and they work together to schedule and execute tasks, maintain cluster state, provide the robust and scalable orchestration. And if you don't visualize it for now, it's okay, because the moment we work with the AWS cluster, I mean, we work with the virtual machines and how to configure and all that, we connect, then we'll start making sense. But just for today, think about, just try to visualize this, try to understand the basic stuff. Okay, now there is two protocol that I want your attention to. First one is the gossip protocol. Now what is the gossip protocol? So gossip protocol is a communication protocol used in distributed system for nodes to send and receive and disseminate information with each other. Okay, so that one server can communicate with each other. That's the thing. Now it's called the and it's called the gossip because it's similarity to spread information in the social networkings. Okay, like social media, you have the gossips, right? That kind of thing. Now this protocol is highly scalable, fault tolerant, and making it ideal for large cluster networks. In Nomad, the gossip protocol is used for tasks such as detecting fail nodes and disseminating information across the cluster. Okay, then The next one is the ACRF. Okay, Self. Now, what is Self? Self is a decentralized solution for cluster membership, failure detection, and orchestration that is lightweight and highly available. Now, it's built like built on the Gossip protocol and enhances with additional features like custom event propagation and query execution. Service used for Nomad to manage cluster membership and perform the failure detection. Okay, so Gossip is a protocol and Surf uses this Gossip protocol. Okay, now uh, we learn about the architecture a bit, and I know you're not gonna remember it too much, but just try to visualize it anyway. If you don't or can't, it's fine. When we do all these server configurations by ourselves in the cluster environment or in the server actual production environment, that I will show in the next week, you'll be able to understand all that. Okay. Now let's learn about the jobs and task groups. Okay. So what exactly is the jobs and tasks? You saw it a few minutes back, right? All those tasks were running via this Nomad, then jobs run, all that part. That is this. Okay. So now let's understand a bit or go into a bit more. Okay, so in Nomad the works that need to be performed is defined using jobs and task groups. Now what are the jobs? A job in Nomad is a declarative specification of tasks that should be run. Okay, and this is the highest level unit of work in Nomad and describe one or more tasks that should be scheduled or should be running on the client nodes, that is Nomad clients, just like we were running. If you see this one in the browser, this one, okay, if you go to clients, see one client is running, that is my MacBook Pro, right? And it have how much CPU, and it have much how much memory, and all these things are available, right? So this my laptop is a client. Okay, and if you see server, it will show my client server only because I have only one node, my current. But in ideal environment, which will have many servers there, and so one will work as a kind of say server. You can have multiple servers. The leader server and other will be working as a client. So leader server will ask about run this, run that, and clients will be running. Okay, so that's there. And for now, just think about client is there available. My machine is working as a client where we'll be running task, and you'll see some tasks are already running. Okay, see node task, there is a node application we are running, and in this, that's how we define things. Now let's go back to slide, and there I want to like discuss a bit more, of course. Now a job configuration is written in HashiCorp configuration language or JSON, and includes details like data center, the region where the job should run, type of the job, task group, network configuration. We write every configuration as a code in our job specification file. Now jobs in Nomad can be different type, including service, which is long-lived, like web servers, batch, that is short-lived, task and complete and then exit. Okay, and system, the task that should be run on every serial node. So all the nodes available, the system that system task type should be running everywhere. Okay, so these are the different types of services available. Okay, now we learn about the jobs. Let's learn about the task groups. So what is task group? So each job consists of one or more task groups, and a task group is a set of tasks that should be co-located on the same Nomad client. Understand that pattern very carefully. Understand this part very carefully. A task group is a set of tasks that should be co-located on a same Nomad client. So whatever you put inside a task group, all that should be running in a single Nomad client. Okay. Now a task within a group are scheduled onto the same client node, allowing them to share the resources and network namespaces. Now this makes it possible for the task within the group to communicate with each other over the same network. Okay, or some virtual networking, you can say, over the loopback interface as if they are on the same host. Okay, so this is how it's engineered, how it's configured. Okay, so if you specify a task group, inside that how many tasks you configure, it will be on a single node and it will be for them so that it can easily communicate between with each other. Okay, now each task group specified one or more tasks along with the resources like CPU, memory, disk space, and networking bandwidth that should be allocated to the group. Just like if you see the code here, we are specifying like what should be the networking and all that inside the group. That's the reason. Okay, now we can actually configure what should be the resource and all that, which I will show the next week. Let's keep the session of this week is very simple as possible. Next week I will complicate a bit more with scaling, load balancing, and the cloud setup, right? Okay, now let's go back to the slides. So we now understand what is the job, we now understand what is the task group, we now understand what is the task. Okay, now let's relate to it. Let's understand the job specification file with the concept that we just learned. Okay, and we are running the application in the Nomad cluster anyway, right? So again, what is a job specification file? A job specification file in Nomad defines that the work that Nomad is supposed to manage, and is written in HashiCorp configuration language or HCL or JSON, and provide a declarative way to specify the task that you want to run. And here's the example. This example is actually the one that I'm just showing here. This is the exact example that I'm explaining in this slide. Okay, let's understand it. So you can see there is a job type, okay, and that is service. Okay, so this job defined as a service, that is a service using this type as equal to service statement. It indicates that job intended to run continuously and as a long running service. It's not like one time run and exit. No, we don't want that. We want it to be continuously running, okay, like web server, like DB servers, like cache servers. We want that to continuously running, right? Or the API server, web server, whatever you want to call it, the server you want to keep it running. Those are the service type that you want to run. Then the group. So what is the group? The job contains a single group, like say here the group, and that is the group name is group node app, defined using the group block. So the keyword is group, and then the name of the group is group node app. You can give any name. Okay, I'm just using my preferred names, and you're using the count equal to, inside the group you see count is equal to one statement that specified that only one instance of the group should be done. Okay, or you don't, if you want to run 3 instance, 4 instance, you can run. It's if your machine have the resources, required CPU and other resources, you can run it. Okay, then the network. So this network inside the group specified that's for this entire group, or the available tasks that we are specifying inside the group will have what are the available networking properties. First, that the mode is equal to host segment indicates that the application will be using the host network mode. Okay, meaning that it will be directly bind to the host networking interfaces. Um, and the port block defines a port mapping for the host port, that is 8080, to the container port 3000. So here you are saying the machine that, I mean, in the machine that you are running this Docker desktop or Docker, all this say Docker desktop or Docker binary, wherever you're running it, there we using Docker command. If you ever used Docker before, we can map the container port with the host port. So that mapping part we are doing with the help of this port node. You can see static in the sense the host fixed port number, and 2 is equal to 3000 means container is actually container, we have specified container port 3000, so that our host 8080 mapping to the container 3000 port. That's what is meaning. Okay, then the group container as a service definition using the service block. The that name is equals to, I mean, you can see the name of the service, that is a service block we're discussing here. So the name is equals to node app SBC. So the service name is node app service. Okay, and that service is the service name. Then the port, and a port will be reusing the port configuration that, I mean, that we have already specified. That's why you can see the port is equal to node port that you have configured in the networking code block. Now then the final part, that is the task. Okay, now what is task? You already know task is actual Docker image that will be running. That container part is this task. So the group defines a task named node task, which is, can see here, node task. And of course, if you go to the browser and go to the visual part, here jobs, say node group job 1, and if you go down, this is the group name. Then if you go again, click on this group names ID, then see the task, node task, click on that, you'll see that is the final task, where you can see the usage and all that. If you keep using, see, you can see it's getting the data usage, the CPU usage and the memories that you can see here. Right now it was idle. Like the moment you use it, then only you can see the spikes. Okay, so that's what you're talking about. So now this task uses Docker driver, and you can see the driver is equal to mention as Docker. So that's why how you're mentioning is a Docker driver you're using. Then the image is equal to Node app v1. Now you can specify any image that you want to run. You can specify here, and it will be automatically pulling all that. Okay, of course, if it's require authentication, then you may need to do some extra configuration. I will show where you can find more documentation on it, so you can follow up. And then is the ports. Okay, now again, ports you have already defined in the node as a node port, right? So you'll be using that name node port, like support is equal to node port. So use the node port available configuration that you are instructing this. Okay, whoa. So you have, with this, let me quickly run again this job specification file explaining what you're doing and what you can see there, and then just I will show the documentation, how you can find documentation, and let's just do that first. Okay, so let's go to the browser. So there you have it here, our tasks or jobs. Okay, so this is the servers, my local MacBook, and the client again my local MacBook, because I am running a single place using the local mode. Then the job we are running the node app job, this one. Okay, and that one actually how we got it, if you go to our code base, there you have this specification file nodejob.nomad.hcl, where you are running things, and you are giving say job is equal to like node app job, type is equal to service. You know, service means continuously running something, like servers. Here also it's a Node.js application server, Node.js app server. Then count, I want one copy. Network, I want to be put, let's say 3000, and static. If you want static, if you don't want static, then the IP will be dynamic. The port will be dynamic. Service, here the name app SVC, the service name. Port, node port, will be just using the same port configuration that you have specified in the network block. Then the provider is the Nomad, so Nomad will provide the this all this app configuration, or this network configuration, or service configuration, what do you call it. Then node task, the task name is the node task. Driver will be using, we are going to run the Docker image, so that's why the driver is Docker. Okay, now the config, where we are giving the image name and the port, that port configuration, simply pointing port is equal to in as an array. Then the node port is actually pointing to this one. So port is equal port node port. So that's how we configure things. Okay, now if you ask me, Sandeep, like there are a lot of things, the service type, the group, this network configuration, the config, the driver, how we can learn more. Okay, simple. I mean, of course you guys might know already. If you don't know, don't worry, you can go to the HashiCorp Nomad this all this documentation, and let me show you where you can get it, and in description section you'll be getting all that, don't worry. Okay, so let's go. Now let me show you the documentation part. Okay, very quickly. This is the documentation of the job specification, and you see developer.hashicorp nomad docs/job specification. This is the URL. Again, this URL I'll be giving in the documentation. I'll be giving the description section, and this URL I'll be mentioning in the description section. You can find it there. So what is job specification? Like how there's the flow, like job, then group, then task. That will be definition will be giving here. You'll use between port and all the service configuration, task configuration, all these things. Okay, you'll be like the resources, like how much CPU and how much memory you want to allocate. Okay, all these things you can specify, even how to parse the environment variables, images, ports. Okay, you can run multiple ports, by of course that's possible. The driver and all that, so you can get all this documentation here, like environment, how to pass the environment, group, what are the additional attributes available for group, so scaling part, suppose for example, so scaling block is available, scaling and all that I'll be covering next week, by the way. Now then there is logs, how you can save logs or check logs, right? Then scaling, or there is scaling definition, like scaling minimum, how many like instance you, like how many copy application you run is like 0, and then based on metrics how to make it or how to scale it. We'll be covering all that later on. Then there is vault and all that thing, this additional will come that later on. Okay, so that is there. Then there is task driver. So overview you can already we already know. So in the code you see we used for driver for now is Docker, right? But in Nomad you can just, it's not up to Docker, you can run many things. Okay, so that's the part you can learn more on that. What are the things you can run? For now I will say Docker. Then there is isolated fork, like if you want to run Node.js or maybe Python and all those kind of application, you can do that via the, like if you don't directly run the application, for those cases you can use the isolated fork execution. Okay, and the driver for this exec. Okay, you can run like say any particular command that you want to run, and you'll be simply running that part. Then Java, for Java you have direct Java driver if you want to use that. Podman, then there is so this that's there, you can have like you run anything like that. Okay, so mainly people uses either the Docker or the Java, or this Docker or exec mainly. If you are running Java, then why not the Java part? Okay, so these are the option available. One special part I want to just mention quickly. If you click on the remote and see, it have the direct integration with the ECS, so you can use Nomad to run ECS tasks, like mainly the forget task. Okay, that option is also available for you. Okay, now we have covered mostly the basics of Nomad, how you can, like what is Nomad, how you can, like what are the reasons or why you want Nomad, the difference between like the Nomad against the Kubernetes, very high level discussion. Then we learn how to run the Nomad. Then let me quickly show the command list, okay, which will be very handy. Let me show you that. Now, this is a very quick Nomad command reference so that you can remember, you will not forget. Even if you forget, you quickly come to this particular reference page and it will retrigger the commands list to your mind. Okay, and see, Nomad agents give you this command, start new Nomad agent, Nomad init. It's get a very blank Nomad file, job file, Nomad job init do the same thing. Okay, then Nomad job run, then space the job name or that is job file name. It will run that job. Then job stop, then it will stop the job. Status is give you the status. For example, if you come to this, let's go to the CLI, and okay, one thing, lot of things running. I have another CLI running. So here, let's run. Let's just minimize this. Okay, Nomad job status. I think that's the one. Yes, you see it's giving like node app job is running and node app job 2 is running. Okay, and how to say what is the priority and all that. No, you don't have to complicate your mind with the priority and all that. Simply think these two jobs are running. Okay, now if you want to stop a job, so Nomad stop job, so Nomad job stop, then this particular ID you have to give, and it is stopping that. Okay, see it stopped. Okay, now, now let's check the browser in UI. Let's see that. If you go to the browser and click on the jobs, you see that Node app job is dead because it stopped this, right? That's the reason it did. Okay, so that's how you can control using different commands. And now you know the commands, right? And you can simply run this command to do certain stuff. That's it. Okay, so you run the job, run, stop, status, node status to see the running nodes, server members to find the server members list, and do all this kind of stuff. Okay, mainly I will say the job part is the main part. Okay, when you run the job and stop it or check the status. That's it. So that's it, guys. Next week we'll be learning how to scale Nomad, how to load balances using console, and of course how to first set up via the Terraform into the AWS cluster. We'll be combining that session for next week. See you guys there. And if you didn't subscribe my channel yet, please do subscribe the channel and give feedback. Of course, I'll be improving further. Even there is a bit work pressure these days, but I'll be doing as much as possible. Okay. See you in the next week session.